In this video, we're going to learn how to construct reflections in plane space. So the first thing here is we need to look at the liner reflection. So in this picture, triangle ABC is reflected over segment DE, and the result is triangle A prime, B prime, C prime. So the directions here say use our compass and our straight edge to create the perpendicular bisector of each of the segments formed by joining the pre-image and image points. So what that means is if we look at the segment from A to A prime, and if we do the perpendicular bisector of that. So I'm going to take my compass, so I'm just sketching that in. Taking my compass, I'm going to go more than halfway, draw my arcs above and below. And go to A prime, do the same thing. So there's some arcs. So if I actually go ahead and connect those, you can see that segment DE is on that line of reflection. So let's continue this process, but let's do it with the other segments formed by joining B and B prime and C prime. So if I go and I join C and C prime, do the perpendicular bisector of that. So we're going to have our compass on either endpoint. I'm just going to lock this in place here because I keep moving it. So go to C, go more than halfway approximately, and go ahead and draw your arcs. Go to the other point, draw on your arcs, and you see that the line of reflection is the same. So the perpendicular bisector is the same. So I can continue this for B as well. So connecting B and B prime. That segment there, we're going to go ahead and go more than halfway. Oops, more than halfway. Draw my arcs. And again, you see that the line is the same. So what that's telling us is the line of reflection is the perpendicular bisector, so we can see that. So that's one conclusion I can make, is that the line of reflection is the perpendicular bisector of the segment formed by each pre-image and image point. So meaning B and B prime, C and C prime. So the line of reflection is the perpendicular bisector of each of those segments. And then the other thing that we're noticing is that the line of reflection is the same every time. So the perpendicular bisector you're getting out is the same. So the line of reflection or the perpendicular bisector is the same for each set of points. So this is going to be important. So if you have to construct or find the line of reflection and you don't have a mirror to be able to look in and figure out where it is, what you can do is you can construct the perpendicular bisector between any pre-image and image point. So that's exactly the process, is just to find the perpendicular bisector. So the next kind of questions here are asking us to kind of examine, well, why is it the perpendicular bisector? Why does that work? And then that's going to help us be able to actually reflect an object in plane space, again, without using a mirror. So if we look at this next step here, it says label the point at which A prime intersects DE as point O. So let me go to my picture here. So A prime is this red segment. Label where it intersects our original segment, which you can't really see anymore, but it's underneath there. Label that intersection point. So let me use black so it stands out. So this point right here, label that as point O. And it says, what is true about these segments? Well, if you think about this, point O is on the perpendicular bisector. So it's on the perpendicular bisector of segment A prime. So that means these sections here have to be equal. So AO has to be congruent to A prime O, because point O is on the perpendicular bisector, and all points on the perpendicular bisector must be equidistant. Equidistant, or the same distance from the endpoints of the segment being bisected. So that is important, because that right there is showing us that the distance from each pre-image point to the line of reflection has to be the same. So this distance here always has to be the same. So no matter where I go, so from C to the line of reflection, from the line of reflection to C, that distance is always the same. So that's why the line of reflection is really the perpendicular bisector, but using that idea is also going to help us when we want to actually find the reflection and perform the reflection. We're going to have to keep that distance the same. And then the next piece here, what is true about each point on triangle ABC and its corresponding point with respect to the line of reflection is what this is supposed to say. Well, we just basically answered that. So every single point on the distance, so let me just kind of shorten this. So the distance from the pre-image, so the starting point, to the line of reflection equals the distance from the line of reflection to the image. So what that really means is those pre-image and image points are equidistant from the line of reflection. That's basically what it's saying. So that distance has to stay the same. And then the other piece here is that when we figure out, so if we go back to this picture for a second, and when I'm looking at the distance and we're looking at this segment in comparison to the line of reflection, these are always going to be perpendicular to each other. So that means when we count, if we're trying to do a reflection, we have to count so that the distance is the same, but we always have to make sure that we're traveling perpendicular to the line of reflection. So that's going to be important when we go to do a construction. It's because a line of reflection is the perpendicular bisector, so we have to keep that distance or those segments perpendicular to each other. So that's another piece that we could add here. So we have the distance is the same, and you always are going to use the perpendicular distance. So I'm just going to say always count perpendicular to the line of reflection. So that's another idea here with that. So if we look at actually constructing this, so let me grab my compass, so compass and a straight edge. So now kind of going backwards, so they're giving us a line of reflection, and you're given the figure and you want to reflect this. So what this is saying is do a reflection, so lowercase r, over line M. So take this triangle and reflect it over this line. So whenever you're doing a reflection, there's two things we have to keep in mind. So let's just write down those two things. So reflections The two things we have to keep in mind is we have to copy the distance, right? So the pre-image to the line of reflection is the same on both sides, and we always have to make sure that when we are counting that distance, so keeping that distance the same to get to B prime, we have to make sure that we're always perpendicular to that line of reflection. So there's two things you have to do. So you have to be perpendicular to line of reflection. When counting. Those are the properties that we just saw up top. And then you're always going to count the same distance. Not count. I'm going to say when copying, because we can't count with a compass. So perpendicular to the line of reflection when copying distance. And then I'm going to say copy distance to the line of reflection, and then go from the line of reflection. So copy distance to line of reflection and go from it. So the main ideas here, you have to be perpendicular to the line of reflection, and you got to copy the distance. We got to keep the distance the same. So what we're going to do is, if you think about each point has to move perpendicular to this line of reflection. So if you remember, we know a construction that allows us to be perpendicular to a line passing through a given point. So that's exactly what we're going to do. So we're going to start with that construction where we're going to start at point B, and we need to measure so that we're going to intersect this line twice. So I'm just going to make sure that my compass is going to hit that line twice, so you can see it will. So I'm going to go ahead and do those arcs. And then from here, using these, we do the perpendicular bisector construction, which will make point B on there. And really, when you're doing this, as long as you just use these arcs, you don't really need to do the full perpendicular bisector. What I'd recommend doing is just going from there. So if I just go here, and then, so I'm only doing partial of the perpendicular bisector, so I need to actually get that. And so from here, what I have now, if I were to actually construct this, I could draw a line that intersects this portion. So remember, I could have done the full perpendicular bisector, got this intersecting arc over on this side, but I only need 2 points. So if I draw a line connecting through B and that intersection, that line is going to be perpendicular to my line of reflection. And then what I need to do is I need to guarantee that the distance between point B and this line of reflection is the same on both sides, because remember, that's how we do these reflections. That distance has to stay the same. But the way that I constructed this, I constructed it such that I made that distance the same. So what I did was I kept my compass the same. And then once I got my intersection points, notice I never adjusted it and went more than halfway. I just used that same length. So since I used that same length that I measured to get to B, what I've done is I've actually forced this point right here to be B prime, because it's actually equidistant from those points, which means the distance right here is the same. So this is kind of the short way of kind of combining these steps versus writing it all out. So really, this intersection point right here is going to be B prime. So the red arcs represent going equidistant, and then instead of drawing in the perpendicular line and then measuring that distance, I just kind of combine it all into one step. I went equidistant, and then I went equidistant again, and that's where B prime is going to go. So it's perpendicular. If you draw a line through it, it's perpendicular, and that distance is the same. So let's just go ahead and finish this up for the other points. So for A, I'm going to just color code this here. And actually what I'm going to do, I'm going to go back, and I'm just going to put like B1 and B2 here so that you know that those came with B. So those came from B. And then when I go to do A, just because otherwise it's going to look really crowded, I'm going to remember, you just have to make sure your arcs are going to cross this line. So I'm going to go here. If it doesn't cross, well, then you just extend it. But I don't want to have to extend it, so that's why I'm just making sure it crosses. So I get my distance so that I get my 2 arcs. And then now I'm going equidistant. So I'm keeping my compass the same, and it is more than halfway. So you are kind of doing the perpendicular bisector. But by keeping that compass setting exactly the same, I'm not going to have to then measure that distance from A to the line and then copy it. So what I've done is I've created a line. Well, I don't have the line drawn, but I could create a line right here that's perpendicular to the given line, which is my line of reflection, and I've copied this distance. So this distance right here is the same as the distance from the line of reflection to that point, because I went equidistant from A to these arcs is the same distance from those arcs to this new point. So all I did was basically 4 arcs all using the same length. So this I'm just going to call A1, A2 again, just so you know that those go with A, and then this is going to be A prime. That's the result. So then the last one I have to do is point C. So it's going to be exactly the same thing. I'm going to shrink this up a little though. And you could shrink it more, but I'm going to make it so that it doesn't cross in between A1 and B2 because I think it's just going to look confusing. So remember, I just need to get 2 intersection points, picking any distance as long as you can get your 2 intersection points. And then from there, you're just copying that distance using those as endpoints. And now you see where point C prime is going to be. And again, you can call these C2 and C1. You don't have to label them. It's just so it doesn't look so confusing. And then C prime is the point I care about. Again, it's the same distance away on both sides of the line of reflection because I went equidistant from those points. And also it's perpendicular because that's really the construction I'm doing. So now the last step, you can see my triangle here. I just have to go ahead and connect it. And then you'll be able to see that it looks like it was reflected, which it should because the orientation changed, because reflections change orientation. I can see that if I were to actually connect these, those segments would be the segments formed, and the line of reflection is the perpendicular bisector of those segments. I can see that the distance is the same. I can see that those segments are perpendicular to the line of reflection. So there's a lot of things I can see to guarantee that this reflection worked. Okay, so that's the process that you're going through. It's really this is kind of why it's working, but the steps are really just create 4 arcs that are the same distance away from that starting point. So that's really all you're doing. So go ahead, try the check your understanding problems, and then we will talk about those in class.